Okay. So, good morning. Let me start. Hello.
Good morning, sir.
Good morning. Okay. So, what we are discussing is basically the scope and the lifetime of variables. So, in our previous class, we have discussed the scope and the lifetime in respect of blocks which are within a same function. So, if we have a function, the function is basically within, say, a main, or there is a function name. In this form, we define a function. Say it may be the main function, or it may be some user-defined function, and there is a scope. This is called the function block. Okay. So similarly, for every function, we have a functional block. The functional block has some assignment at the top, then it has some statements, and finally it returns. Okay. So whatever we have discussed, the lifetime and the scope of variables, that is basically within a particular functional block. So in this lecture, we'll try to understand that when the control moves from one function to another function, then how the variables are maintained in the memory, and what is the scope and lifetime of those variables. Okay. So, okay. So in this case, whenever we are talking about a call from one function block to another function block, then the scope of the scope is limited within the functional block. So it means, say, I have a main function, and in this main function, I have defined the variables, say integer I, character C, and then I have made a call to another function, something like this. Okay. And in this case, I have another integer, say character X in this. Okay. So when the control is within this function, when the control is in the main, then all the variables which are defined in the main, they have their scope and also the lifetime, depending on the blocks that we have already discussed. But when the control moves from one function to another function, then the scope is only limited within this function. Scope is only limited within the functional blocks. The scope cannot be translated, or the scope cannot be transferred from one function to another functional block. Okay. So whatever the variables which are defined in this function, they are under the scope of the executions, and they are the memory is available for those variables. Okay. And so we say that the scope is resolved basically by the current functional blocks. So if we have multiple functions called, say main calls a function 1, for function 1 calls a function 2, and my control is within the function 1, then all the variables which are available in the function 1, they are under my scope. If function 1 calls the function 2, then all the variables which are only defined in the function 2, they are under my scope. Understood? But the lifetime is having a different scenario. The lifetime says that all the variables declared in the current functional block and all its preceding functional blocks, they are alive. So that means, so in this case, if I draw the part, so say this is main, This is fun, and we have the scope of scope, life, scope and life. Okay. So when the control is within the mean, then this scope is available, the life is also available. But this scope is not available, the life is not available. When the control is within this function, then what happens? This scope is available, the scope of mean is not available. The life is the function, all the variables which are defined in this function, they are alive. All the variables which is defining the mean, they are also alive. But those variables cannot be accessed from from this functional block. But those variables remains into the memory and they are shaded, so they cannot be accessed. Okay? So when the function returns from this functional block to the main, then again those variables become their scope become open and their lifetime is remains. Okay? Understand? So if there is a function call from this one to here, then this one to that. So if I am in this function, in this functional block, then all the variables which are defined in the top, say f1, then f2 and f3, all those variables are alive. They remains into the memory. Okay? But f1 and f2, the variables are not possible. When the control returns from f3 to f2, all the variables which are defined in f3, they destroy. They do not exist in further. But the thing is that now all the variables which are defined in f2, their scope becomes open and they are now accessible. Now when f2 returns from f2 to f1, all the variables in f2 are destroyed and the scope of f2 become open. Understand? You get this point? Hello, Vicky. Am I?
Yes, sir.
Okay. Okay. So let us try to understand with an example. So in this example, what we are doing, we are basically trying to find the okay. Let me draw this function. So we have a main. In this main, we have two variables, int I and sum. There is another sum is variable. Then we have a function call of I, and function I or integer, it is defined function integer function, and then it does something return function. So it returns function, and it is an integer. Okay. So what is the scenario? The scenario is that when I am in the main, okay, so I have the variable I and sum. Okay, understand? And when I am in fun, then I have defined, when this call is happens, then I have defined the function. Okay, these variables is now defined. Okay, then when the control enters to the function, these variables is defined. Now when the control is in the function, then these variables are not accessible. They are not. I cannot see the variables from the function, but I can only see the variables in the function. In the function, I cannot see the variables in the main. So when it returns, then what happens? This function is deleted. This function some variable is destroyed from the memory, and it returns the control to the main, and then all the variables which are available in the main, they are now visible. Okay, understand? So we say that when control is within main, the variable I and sum are visible and they are alive. So this I and sum is available for the programming and they remains into the memory. When control goes to the func, means this is a function, and the variable x, so there is a variable x is defined within the function, then there is a variable fun sum is defined. So their scope is now available, their lifetime is now valid. Okay. Understand? But when the control returns from this fun func to the main, then these variables x and func sum, these variables are also destroyed. The variables destroyed and their scope is also invalid. Okay.
Yes, sir.
Okay. Now let us take an example that what we are trying to execute in this case. So let we try to find the sum of first n digit. Okay. And we have defined a program. We have defined a function which basically takes an integer and add the value with its previous value. Means we are basically computing the series of addition in the function in the function fun. So what we are doing, we try to initialize the I. I is basically the iteration, how many times we have to compute the addition. Then sum will accumulate the result in this way. But I am not executing the summation in the in this main. Rather, I am executing the summation in a function called which is named as a fun. So what fun does? Fun, we are assuming that fun will have a func sum. So we are assuming. So this is our assumption. Assumption that fun it will contains a container which is named as func sum, and it takes an integer as I. Okay. So the main it will make a call of sum equals to func of 1. Then it will add this I in this container. So this container will have the value of 1. Okay. So when it returns the func sum. So at this point it will have sum equals to 1. Okay. Then in the second iteration it will call func 2. Then I will take the value of 2. Then I am assuming that the operation will be func sum, which is already having the value of 1, and then it will take the value of 2. So it will be the 1 plus 2, and it returns. So now we'll have sum equals to 3. And in the third iteration, as our assumptions, we apply 3. We pass the value of 3 to this function. Then we are thinking that func sum will have the value of 2 plus 1 plus 2 previously, which was computed, and now 3 comes here. So it will add it with the things. So when it returns, we'll get sum equals to 6. Yes, so that is our assumptions. Assumption saying that we are assuming that this function will remain in the memory. So we are assuming that function remain in memory whenever we return from the function, but that is not true. The function, whenever it return from the function, this function also destroyed. So we are assuming that for the first call, the function will store the value of 1 and it remains into the memory. When the second call happens, then function will have the value of 1, then we add it with 2, so it will become 3. In the third call, function will have the value of 3, and then we add it with 3, then it becomes 6. But this condition, these things is not true, because whenever the control returns from the function, the variable is destroyed. So there is no previous history of the variable. Okay. So this program is basically does not compute the value. So every time we enter into the function, we are having a fresh initialization or the fresh variable. we are having a fresh variable, we are having a fresh variable as function. So the previous value, the previous instance was not existing. Understand? Get it?
Sir, can you use for loop
Do you get this
in
point?
int function?
That we can do, but our intention is to understand that if we try to access the history, history of the variable in a function, then this is not possible. That is the main intention of this function, of this means implementation. Understand? So this implementation is not correct. I am sure. I am saying that it is a faulty program. But why it is a faulty program? Because this function is not existing to the memory when it returns from the function, from this function FUN. Understand?
Memory stores only int main.
No, memory does not exist when it returns from the function. So what is happening? It is happening that I am calling the function here. For I equals to 1, sorry. For I equals to 1, I am calling this function. Understand? Get it? For I equals to 1, I am calling this function. So this memory is created here, and they performs the operation. So it returns function equals to 1. So I push this one in the argument. So initially it is 0. So 0 plus 1, it was 1. So it returns. So now sum accumulates the value of 1. Understand? Clear? Then what happened? Then everything is destroyed. Everything's in this memory, they destroyed. Okay? So whenever I have the second call to this function, then the value which was previously available in the function, that value is no longer exist. So again, there is a new instance of these variables created. Again, there is a new instance of sum created. That was initialized with 0. Then the operation will be 0 plus 2, because I am passing the 2 into this function. So it will return 2. Instead of 3, it will return the 2. Understand? So the previous value which was available in the function was 1. That value was no longer existing to the memory. Understand? So that value, that variable is destroyed whenever it returns from the function. You get this point?
Yes, sir. So
that is the difference. The difference is something. Then what is the another part? The another part is when this function, when the call is happens, then every variables in the main, they are alive. Here, their scope is not destroyed. Their scope is not available, but they are alive. Here, so this sum will not be when function returns, when the control returns from function to main. Then see, this sum is not newly created. This sum will remain because their lifetime is valid. There is a function call. This is the base function. This is the calling function. So when the call is happen, then every variable in the main, they remain into the memory. Here, they are not destroyed. But when the function is returning, then everything which is defined in the main, in this function, they are destroyed. Get it?
Yes, sir.
Yes, sir.
Okay, so
yes,
let's take it from here. So it says that this is the scenario. There is in the main, we have the variables I and sum. In the function, we have the variable x and sum. So these are the variables. One is I in the main, sum in the main, x is in the sum is in the fun. So this is the variables which are available for my program. So when control is made, then what happens? The I will take the value of 1, sum will take the value of 0. So in this case, I is taking the value of 1, sum is taking the value of 0. So at this point, so at the for loop, at the beginning of this for loop, I is taking the value of 1, sum is taking the value of 0. Then we have a function call. So when there is a function call, then what happens? This control is going from this main to the function. So these variables are not accessible. So they are shaded. I cannot access the variables, but their life is remains. So they remain into the memory. They are not destroyed. So I will having the value of 1, sum will having the value of 0. That things remain into the memory, but they are shaded. Then what happened? Then we are into the function. So x is now having the value of 1, sum is now having the value of 0. So I pass I equals to 1 to x. So x is now having the value of 1, sum is now having the value of 0. So now what happened? It assigned the func with the value of 1. So what happens? So in the bottom it says that the scope is invisible, lifetime is valid. So in the main, the values are not visible, but they remain alive. In the function, the scope is visible, the lifetime is also valid. So in this case, I am able to have the access to this variable and they are alive. So now what happened? So now when it returns from the main, then everything's destroyed. So the func visibility no longer exists. So these variables are destroyed. X is not available, func is not available. Then what happens? The value which is returned, they came into the main. And now the main will having their variables with their scope and the light. So now the shaded part, in the previous slide, what was in the shaded, now when it returns to the main, the shaded part is vanished, so they becomes accessible. So the program says that when it returns the func. So the func is assigned to the variable of sum. So we'll get the value of 1 in the sum. Understand? Get it? So now the second call happens. Okay. Now when the second call happens, I will take the value of 2 and x will take the value of 2. So when the second call happens, I will take the value of 2 because I is incremented by 1. Then we have made a function call to the variable of x. Then what happens? A new fresh assignment of the variables was done. So x is newly created, it is assigned with the value of 2. Func is newly created, it is assigned with the value of 0. Because in the program, you'll find that x is taking the value of I and func sum is taking the value of 0. Okay. So the new variable is created, they are having their new assignments, and then what is the output of this function? Then the sum will be sum plus x. So now the sum will carry the value of 2. Okay. And it returns to the main. So when it returns to the main instead of having 3 means 1 plus 2 plus 3, 1 plus 2, which should be 3. Now it only contains the value of 2. Clear? Because the previous history of the func, which was 1, that was destroyed. Clear? That was destroyed. A new instance of func sum is created, and that was initialized with 0. A previous func sum variable which was created in the first call, that things no longer exist into the memory. Understand? Clear? You get this point?
Sir, in the previous slide, it is written the scope is invisible. So why, sir? In the previous slide. Yes, sir.
Yeah?
In this, sir.
This slide.
Yes, sir. Scope is invisible. Why, sir?
Oh, what's it? No, this is visible. Okay, take it correction. This scope is visible. Understand? Okay, this is the copy paste problem. I copy paste that this is happening. Okay, take it is visible. Okay. Understand? So what is happening? The problem is something like this. In the main, the sum must take the value of 2 plus 1. Means previous value of 1 should be stored in the memory such that I can put an addition 1 plus 2. But this previous value of func sum was no longer exist. So the problem is the program is basically erroneous program. Understand? But it returns the value of 2. It calculates the value of 2. Okay. So subsequently, if you go keep on doing these things, if we run the program for n number of times, every times the sum what will carry. Say if I run it for 10 times, then what will be the result for this sum? So does it computes 1 plus 2 plus 3 plus up to 10? It does not compute something like this. So what will be the output? Any guess?
Sir, I think it will be 10.
Sir, it will print 1 to 10, sir. Just print 10.
16.
It will only print the sum. This print statement is not in the for loop, so it will print the final sum. So what will be the
So
output?
that's 10. That's 10.
10.
10, sir.
10. Because all the previous accumulation, they have no effect, because this element is every time this element is destroyed and newly created, destroyed and newly created. Understand? Yeah. Get it? Do you understand this point? Okay. So, so in a nutshell, what we okay. So this is basically the understanding. The understanding is something like this. Say there are three functions. So the function 1 is calling the function 2, function 2 is calling the function 3, and the control is moving something like this. Number 1 is the call from function 1 to function 2. Number 2 is the call from function 2 to function 3, and they are returning in this way. Okay? So when the control is in the function 1, then in my memory, the variable of x and y will be available. Understand? Yeah. And they are having their lifetime and the scope. So when we move to the second part, then the control is in the function 2. Then his variables, which are the member of the function 1 and function 2, they are remaining to the memory, but their scope is not visible. Understand? A new instance of x and z will be created, and they are basically the member of the function 2. Okay? So their scope and lifetime will be available. And then when we move to the function 3, then all these variables, which are the preceding functions, which are available in the preceding functions, they are all, their visibility is all shaded. So they are not visible. A new instance of z and y is created. Understand? And all the operations is performed with this variable when we are in the control of function 3. Then when we returns, then these variables, means the variables in the function 3, they are destroyed. Then the calling function returns, the called function returns to its calling function. So z function 3 returns to its function 2. Then all the variables which are available in the function 2, their scope is now available. Understand? Their lifetime is already valid, so their scope is now become accessible. So it can have the previous values. So means whatever the values which are defined in the x in function 2, they will be now active. Yeah, whatever the value is defined in z in function 2, they are now become active. Understand? And if when the control moves from function 2 to function 1, then everything's in function 2, they are destroyed, and now function 1 element are become visible. Okay. So this will also give you a sense that we are using the variables, we are using the same variable, means not the same variables, they are basically the name of the variables are same. We need not to have say distinct variable names in different functions. So I can have the same names, like in I can use the I variable name in different functions, and they will not collide to each other. They will not have ambiguity to get that which I am getting access. So if I am in the function, if I am in the say function 3, then this z, whatever the scope is basically for the z which is defined in the function 3. So all the operations on z variable is only having the effect on the variable z which is defined in the function 3. These operations of z will not having any effect on the variable z which is defined in function 2, because these variables are not, their scope is not valid. So there is no ambiguity that I am in the function 3, and if I write some statement z equals to 20, that will be update the value in the function 2. That will always update the value in the function 3. Understand? So you can use the same variable names in different functions without any ambiguity. Okay. Understand?
Yes, sir. Sir, one question.
Yes.
Sir, is there any scope of global variables in C?
Okay, I'll talk about these things. But presently, we try to understand that the variables which are within the bind of a block. So within a function block and in different function blocks. I'll just After that, after this part, I will discuss the global variable. Okay. So, so this is basically the scenario. The scenario is there are two characteristics that depends. There are two types of scope and variables. One is within the functional block. Means I am working within a functional block in this way. Okay, let me just draw it here. So I have working within a function block. So this is a function block, and within the function block there may be some more blocks. So there may be some if block, iterative block, or within the iterative block there may be some another block. So iter the if block. Say this is for block. This may be another for block in this one. So I can define variables on the fly. So I can define variable I here. I can define variable I here, or say X, something like this. Okay. So that the first part of the scope and variables that defines that how these variables will be having their scope and lifetime. So it says that if it is something like a stack of scenarios. Say so this is the main functional block. Say then I put another functional block on this top. Let me arrange in this way. Say I have a say what I can say. I have a textbook. So this is one book. Then I put a small size book on top of that things. I put another small size of book top of that things in this way. So when I am in the lowest level, so I always look at the down. And we say that what are the variables we have defined in this lower at the very lower end. They are accessible and their scope is valid. If I am in the top of this second block, then I am looking down and I am able to see that what are the variables which are defined here and which are defined in this block. So their life and their scope is variable. So when I jump to this block, to the lower block, then everything is destroyed at the upper block. Understood? And again, I run with this variables and scope which is defined in the lower block. Again, if I jump to the top of another block, then new variables appears. And I am looking down. What are the variables which are accessible? So I am access those variables as well as the variables which are defined at the lower block. If I jump on the top of these things, then I am again having some more variables. So now I can see all the variables downwards. So the variables at this top, then the variables at the second layer, the variables at the third layer. And when you jump from the top to the second layer, everything's on the third layer destroyed. When you jump from the second layer to zeroth layer, everything's in the second layer, they also destroy. Okay, so this is the concept of within the functional block. So lifetime and the scope is basically bounded by the block structure. So when we enter into a particular block, then I am able to see all the variables which are defined in the block and all the variables which are defined in the preceding blocks. Yeah. Now, in a function, the case is a little bit different. So when we are having two functional blocks, yeah, and this is the calling function, and this is the called function. Okay. The control moves from calling function to call function. Then all the variables here, their scope is not available. Scope is invisible. The lifetime is valid. Time is valid. Now, here the scope is valid. Scope and lifetime is valid. Valid. Now, when the control returns, say, when the control returns from the part, say, so when the function returns from here to these things, clear? Then what happens? These scopes are destroyed. This scope now becomes visible. Their lifetime is already alive, so there is no problem. Okay. Understand? Get it? So when I move from one function block to another function block, I keep all my things in a suitcase. They are alive, but they are not visible. I work with a different function block. When I return from the different function block to my calling function, all the things that I created in the call function, I destroy the things. I return with a bare hand. Understand? So that is basically the concept. Okay. Ready?
Yes, sir.
Fine. Good. Then, okay. So the question is that, so the problem is something what we have seen, that when we return from a function, then everything is destroyed. That is one problem. So how can we overcome the problem? I want to store some values, which because I have to keep the history of the variables which are available in the called function. Okay? And in that case, there is a keyword which is called the static. So this static is basically used if I want to create the instance once, and the lifetime of this instance will be throughout the executions of the program. Okay? So it says that static is a variable. It has the lifetime extended to the termination of the execution. Means whenever main terminates, then the static, how long the main will be alive, the static variables will be alive in the memory, and they will keep the history of the previous operations. Understand? Yeah. So if we don't use the static, then the simple concept is that when we return from the function, the variable will be destroyed. So if we define the variable as a static, then it says that when we return from the function, the variable scope is not visible, but they remain into the memory. They remain alive into the memory. Yeah. Then whenever we make a second call to the function, the previous history can be accessed. So whatever the function we have defined in the same function is now redefined here, but we just make the variable as a static. So whenever we make the variable as static, then it initialize with a value of 0. Then the first function call, first function call with fun equals to I means 1. It assign the computes the function with a value of 1. Then when it returns, the value remains into the memory, but their scope is not visible. Clear? So it happens something like this. When we have the sum equals to fun of 1, then this fun 1, it stores the value of 1 in function. Sorry, what are the variables? Function, and it returns. Okay. So whenever we call a function of sum equals to fun2, then it is basically retrieve. It is basically recall the previous history, because this variable is not destroyed. When it returns from the function, these variables remain into the memory, and it is not destroyed. So now we assign the things with a 2. So now I am having the effect that 2 plus 1, now it becomes 3, and it returns 3. So it will return the 3, sum will take the value of 3. So when we have sum equals to fun 3, then this will becomes 3, then it will add a 3, so it will becomes a 6, and now 6 returns. So sum will take the value of 6. Okay. So static is basically a keyword. It is we call these things as a specifier of the variable. So static specifies that I want to keep the memory alive, even we return from the function. Understand? So when we are returning from the function, I want to keep this variable alive. So that is the mean of the that is the implication of a static. Okay. Understand?
Sir, meaning the variable is alive, but we cannot access the function in the main block, right?
No, we cannot access the function.
Yes,
The function from the main block. but it is alive. So I can get the history when we call back to the func. Understand? That is the issue, main things. Okay. Then, so there are, so at present we are not doing more of these characteristics. We try to understand that there are three types of variables. One is called the global, another is called the local, and another is called the static. Static, we understand that it is a local variable and its lifetime will remain still the executions of the program. Means how long the main will alive, the lifetime of all the static variables will be available. Clear? Local, we understand that whatever we have so far, whatever the variables we have declared, they are called local variables or auto variables. Clear? And global is basically a variables which are defined outside the main. So C will also provide you facilities that main or any function. So I have the variables which are within this part. So they are variables within the part. But I can define a variable which is globally available. So we call these things, say, integer x is globally available. So when the program executes, this global variable is always having their scope and lifetime. Okay. So from anywhere, if my control is within main, I can access the global variable because its scope is open, its lifetime is open. Whenever I move from here to the function, this global variable having its scope as open, so I can also access the global variable x. Okay. So global variable is basically the variables which scope and lifetime is always open. Means, their lifetime is valid throughout the execution of the program, and their scope is always open. So, so sometimes I say if we want to define a matrix or the size of the matrix, say I sometimes write int size n in the global is equals to 10. Okay. So we need not to redefine the size of the matrix in different different blocks, in functional blocks. Okay. Because it is already defined in a global. So it is basically a constant type of scenario, which says that okay, now every function will have the size of a matrix as 10. Okay. So sometimes we can use this type of variables as a global variable. Okay. Understand? So global variable all through the executions, their scope and lifetime is available. And the local and the statics are as we have already discussed. In that way, we will handle the local and the static variables. Okay. So we have another. We can there is a last things that is related to the function call, which is called the call by value and call by reference. We'll discuss these things in the next episode. Okay. We will take 2 or 3 more classes. One is related to this function. Yes.
So can you describe about the argument?
Argument is basically means what is your problem? Argument is
in code. What is the argument? Well, we have to assign argument in function or in main function or in particular function.
No, argument is basically this is a if I am writing a function, if you in C, then argument is the value which will supply to compute this function. Like if I take the example, this example. So main is calling a function which is fine, but it calls a function with some assignment. So I am supplying the integer I for computation of this function. So this I is called the argument to this function. Understand? Yeah. So
that means int function x is equal to I. X means I here.
Okay, that is the problem. In your next class, we will understand that what is happening when we call a function with supplying a value. Understand? Okay. That concept will be clear when we discuss the call by value and call by reference. Okay. So simply means I have a function. Say in mathematics you are writing something like this. Say I have a function which takes x and y and it returns say x plus y. So what is the argument to this function? The argument is there are argument 1, argument 2. Okay, understand? So this is the argument. So if I write a function something like this, sorry, there is nothing to be discussed. Say 2 to the power 5. Yeah. So this function does not take any argument, but it always computes you 2 to the power 5. Okay. So you have a void argument. Understand? So your function may takes argument something like this. If you want to supply something argument, some initial value for the computation of the function, then we assign some input value to the function. So we call these things argument. If we don't need any initialization for the computation of the function, we have a void argument. So, but your question is that how if I called func I and here I am writing func x, then what is the relationship between the two? So we will discuss this thing in the next class. Okay.
Okay, sir.
So our planning is that we'll discuss, we'll cover the call by value, call by reference, and then we also have a small session regarding the recursion. Recursion is a part when the function is basically calling this itself. So if I have a function something like this, say function 1, and within this function I am using the same call function 1. Okay. So this is basically called the recursion. So I am basically calling the same things again and again. Here. So what is the implication of recursion? That we'll also discuss a bit in our course. Okay. Any question? Any doubt?
No, sir.
Sir, macro can be treated as global variable in C.
No, macro is not a global variable. Macro is sometimes called a substitution. Macros are defined in the global part, but they are not the variables. Understand? We have not touched the macro. So it is like, so we define, sometimes we define, say, hash define, right? Define max is equal to 20. Here, so this appears in the global part. Here, so this is not a variable. It is basically a constant string which replaces this this part. So if I use in my program name, say int 5, int x and x equals to max. Here, that means this is a symbol which replaces the right hand side, which basically, so this string replaces with its right hand side. So whenever the compiler executes these things, before the compiler executes, it replaces the max with the value of 20, with the constant string of 20. Understand? So before it compiles the program, it replaces max with 20. Okay. So now the thing is something like this. It is not a variable because I can also write some statement here. So like max is equals to x greater than 5. Here. So whenever I write max, then before compilation, it will simply substitute the max with this string. So this is simply a substitution, x greater than y. Understand? Here.
Yes, sir.
So
X greater than y 20, what does it mean then?
No, 20 is not there. Means 20 is not there. Means now we have redefined the macro. We have defined the macro as X. Let me make it clear. We have redefined macro max, say, or compare. So let me define another macro. COMP, meet X is Y. Yeah. So whenever I write comp before the compilation happens, this macro will be replaced X is less than Y. Understand? So this replacement will take place before the compilation occurs. Okay. So the macro is sometimes called a replacement. Means I want a replacement of a string by some tag. So I am having a tag. That tag, if I use in my program, before the compilation, that tag will be replaced by a string. Understand? Okay. So don't consider these things as a global variable. It is globally happens, but it is not the variable. Okay.
And sir, do we have concepts of functional overloading and encapsulation in C?
No. Functional overloading encapsulations are not available in C. C that is available in the object-oriented environment. Okay. It is a procedural language. C is called the procedural method or procedural language. So we don't have the concept of overloading or encapsulation in C. Little bit encapsulation is available when we define a structure, but we are not having the time to discuss structure. You may learn these things when you learn for the data structure course. Okay.
Okay, sir.
Okay. So, okay. So let me stop my recording.